So good evening everyone and welcome to today's lecture. This is electrostatic lecture number 7 and we still have to start electric field lines and electric flux and Gauss law. We are still stranded. In the last class I think we had seen all these questions which had different holes at different places, and we had to find out electric field in vector form in different combinations. And I told you one of the questions from one of the previous year JEEs. Anyone tried it? This one? And got the answer?
Say k equals to 6.
K equal to 6. How many of you got this answer? K equal to 6. Well done. Hannah sent me the solution on the WhatsApp or Telegram group. That is correct. K is 6. The only thing that you did not know in this question was to how to find out the electric field created by this one. This is a solid cylinder. The answer is what they have given. That is correct. How we will get the electric field due to this one? I will not tell you the answer. We will first go through Gauss law. After Gauss law, you should be able to find out the electric field on your own. As Hanak sent me the solution, his concept is absolutely correct. You can take this as a line charge as well for infinite. For any point outside, this just behaves like an infinite line charge as well. Anyways, well done. So I guess we are improving day by day, and that is a good sign. Remember, whatever has happened in 11th standard is of no consequence right now. Most of the topics that are scoring, I am covering them for you, right? So don't worry about anything that is left. I will be covering your entire course before you sit for any attempt of your JEE. Having said that, let us now first move on to, I think we are done with electric fields for now. Let us now move on to the next heading, and the next heading is electric field lines. Now we will deal with those electric field lines, and there are some really good problems which can come. Most of the problems for electric field lines would be basically theoretical in nature, where what, where they are going to give you the diagrams and they are going to ask you something. So we will deal with those problems in this particular section. So you can write the heading. And what is the heading that you're going to write? Electric field lines, or sometimes they are known as lines, electric lines of force. Doesn't matter how you write them, you just have to write the heading electric field lines. And where is that? Electric field lines, or lines, electric lines of force, you can call it. Electric field lines. Now I think you have this topic also covered. Yes or no? Is this topic already covered? Electric field lines, and I can go quickly. Is this covered? Or shall I go slowly?
Covered, sir.
It is covered. So then I will move quickly through this topic. And
No, sir.
yes, it's covered, no?
No, sir.
No, sir. So I get no, sir. So I will move slowly. Don't worry. I am expecting that you might get a question based on this. So I will go according to my assumption, and where I was looking at a diagram, and where the diagram has gone. This is not there. This is not there. All right, where is the diagram? Tick flux again. I will have to look from the very beginning. Electric field lines. What do you understand by electric field lines? Anyone, any idea? Someone said that electric field is already being covered. So can you tell me what do you mean by electric field lines? Or electric lines of force. What do you understand by electric lines of force? Tell me. No one knows it? Here I have. Electric field lines, or electric lines of force. Anyone? No one knows. The topic has been covered, but no one knows. That means the topic is not covered. What are electric field lines? Say. No one knows. Something you will know about them. No one knows anything.
Imaginary lines which are tangents to electric field.
Okay, so basically, when we have to imagine this electric field, field lines help us in imagining those electric field, and we draw them to understand how this electric field is acting at different points. So the first thing that you must remember about electric field lines are they are imaginary lines. So write it. They are imaginary lines. They are imaginary lines drawn in such a way what?
Tangent to the direction of electric field.
That the tangent drawn at any point gives us what?
Direction of electric field.
Gives the direction of electric field. Only the direction. What about the magnitude? These are imaginary lines drawn in such a way that the tangent drawn to any tangent drawn at any point gives us the direction of this electric field lines. Remember, they are imaginary lines. They just exist in our imagination. Okay, they just exist in our imagination. Do we understand this? Now, whenever you draw this imaginary line, they start from where? They start from a positive charge. They start from a positive charge and they end on a
Negative charge.
and end on a negative charge. They start from a positive charge and they end on a negative charge. The other way of saying this thing is they are always in open loops. They are in open loops. They are in open loops. This is the other way of saying the same thing. They start from a positive charge or they are directed away from a positive charge and they always end, electric field lines always end on a negative charge or they are directed towards a negative charge. Do we understand this? And these are the two diagrams that will probably help you understand the same thing. If you see electric field lines going towards a point, that means there must be a negative charge over here. As you can see, this is a positive charge and electric field lines are emerging out from this positive charge. Here you see a negative charge and you see electric field lines going towards that negative charge. Do we understand this?
Yes.
Now, many a times the questions on this, and I've seen question come in JEE on this electric field lines, and they are basically to draw the lines or, from the lines you have to find out whether the charge is positive or the charge is negative and all. So this electric field line becomes a good theoretical concept and you can have some good theoretical questions based on this. So you'll have to understand the theory behind this. This one, the third one, as you can see, let me make it bigger. This is the electric field lines of two positive charges, and as I can see, they are two equal positive charges. If they are unequal, then something else would happen. I hope you are able to understand this and you can draw a rough diagram. Oh, sorry. This is the electric field due to one charge positive and other is negative. One is positive, the other is negative. From the positive charge, electric field lines are going out. From the negative charge, towards the negative charge, the electric field lines are going in. Anyone sees this, yes or no? Then this is the electric field lines due to two positive charge, two negative charges. It will be the reverse of this. Instead of electric field lines going out, electric field lines will be coming in. And you can see there is no electric field lines in this space. That means there is no electric field there, literally. Everything about this electric field lines or electric lines of force is theoretical, and you must remember them. Let me know once you have noted it down. So that I can move ahead in life. Most of the questions that you're going to face on this chapter will be theoretical in nature. Trust me on that. You just need to draw a rough diagram just to give you an idea of what is happening here. That's nothing. That's all. You don't need a very fair diagram. This is just, they're not going to ask you the diagram, bacha. What they are going to ask you is which diagram belongs to what, or which is what charge, which charge is more, which charge is less. That is only that they are going to ask. This should give you an idea of how these electric field lines are, nothing else. Nothing more, nothing less. Do you understand this? Just need to have a fair idea. Have you noted it down?
Yes, sir.
Everyone, boys? Boys are noting down. Okay, note it down, don't worry.
Sir,
Yes, beta.
why field lines are curved?
Why field lines are curved? We will come to that because they cannot cut or cross each other. That is why they are curved. So whenever these electric field lines from one charge is coming to the other charge, they cannot cut or cross each other. So they have to become curved. That is why they are becoming curved. That is the next point that we are going to do. The next point that we are going to do. Why they cannot cut, cross each other or touch each other? Yes, anyone? That is the next point. Have you done this?
Because field lines can never intersect.
Why? Or touch? Why? That is what I'm asking. Have you drawn this?
There is a lateral repulsion.
Lateral repulsion. Okay. Lateral repulsion, they repel and they attract. That explains the attraction and repulsion between the two charges. Yes. Why? But that is definite. That not the exact answer, but yeah, somewhere close to an exact answer, but not the exact answer. But I can't call it a wrong answer as well. So, but it's not right. But obviously, it may not be wrong as well. Yes, anyone with any other idea? Have you written this first? Have you drawn this diagram first?
There will be only one tangent.
There can only be one tangent. Why? Why can't I draw two or three or four or five? Huh? There can only be one tangent. Yes, but why I can't have two or three tangents? Why I can't have two or three tangents? Huh? Tangent isn't mine. I can draw. Doing. I can draw a lot of tangents. What will go wrong if I draw a lot of tangents? Remember, beta, the electric field at any point can only have one value. It cannot have two values. It can only have one value. It can have only one value. Therefore, it can have only one direction. If I talk about this point, electric field here will always point in any one direction. It can keep on changing. That is different, because if you change the charges, it may keep on changing, but it can only have one direction and one value. Now it can have only one direction and one value if the field lines cross. That means there will be a problem. Electric field at any point is because of the net electric field created by all the charges in the universe. So this electric field is the summation of all these electric fields. It will only point in one direction. Right now it is this direction, and therefore two electric field lines cannot cut, cross, or touch each other. That is the next point that we are going to write. Electric field lines cannot cut, cross, or touch each other. Because if they cut, cross, or touch, you can draw two tangents, which is not possible. EFL, electric field lines, can't touch, cut, or cross each other. Do you understand this? Yes or no? Yes or no?
Yes, sir.
Okay. So far, so good. Now, it cannot cut, cross, or touch. The next thing is the number of electric field lines. Now, we have seen that these electric field lines come out of charges. If it is a positive charge, it will come out of the charge. If it is a negative charge, it will actually go into the charge. Depending on the magnitude of the charge, the number of electric lines of force that originate from a charge or which terminate on a charge is proportional to the magnitude of the charge. Do we understand this? Small charge will have small number of electric field lines coming out or going in. A large charge will have large number of electric field lines coming out or going in. Do we understand this?
Yes, sir.
A small charge will have small number of electric field lines, and a large charge will have a large number of electric field lines. Now, looking at the diagram, I'm giving you examples with the diagram so that you understand what we mean. Now, looking at this diagram, can you tell me which charge ka value will be more? First of all, you can tell me which charge is positive and which charge is negative. Remember, electric field lines is all theoretical concept because it is imaginary. Yes.
A is positive, B is negative
A is
charges.
positive and B is negative. Keep that positive and negative apart. Which is having more charge, A or B?
A.
Why A?
More, sir.
Because more electric field lines are coming out of it. Do we understand this? Yes or no?
Yes, sir.
That is what we need to understand, that the number of electric field lines coming out or going in a charge tells us how big or how small the charge is. Have you noted it down, bacha? Shall we move on to the next point? Huh?
Sir.
Okay, something has happened. So I will have to restart it. Give me a minute. Things happen. This, which is one? This one. Okay, we come back. Okay, now this is the next heading. Now, the number of electric field lines passing per unit area perpendicular to the area, or basically looking at the number of field lines, if they are very dense, very crowded, very close, that means the electric field is stronger. Close electric field lines, densely packed electric field lines means stronger field. So the number of field lines that are drawn tells us how strong or how weak the field is. If the field lines are very densely packed, that means it is a stronger field region. If they are distance line, that means it's a region having a weak field. So number of field lines basically tell us how strong or how weak the field is. It is similar to saying if the charge is large, field will be large, and therefore the number of electric field lines would be more. Do we understand this? So these two statements actually come side by side of each other. They actually refer to the same thing. Do we understand this? Yes or no? Huh?
Sir.
So now looking at this diagram, have you written this? Have you noted it down, bacha?
Completed, sir.
Boys?
No, sir.
Take your time, take your time. Remember, we are not in a race. This is no race. Not a part of a race. You have to understand what we have to understand. Take your time to understand things. Don't be in a haste. Understand them, because you never know. You may just get a question on this, and in your hasteness, you might miss some important point. Remember, whatever I'm telling you, everything is a potential question. Trust me on that when I say this. So note down everything carefully. Everyone done?
Done, sir.
Okay. Then this. Now look at the diagram and tell me where is the field stronger and where is the field weaker.
E2 has the more. E2 is stronger, sir.
E2 is stronger and E1 is weaker. Do we understand this? Yes or no?
Yes, sir.
So how did you get that point? We just looked at the number of electric field lines, and looking at the number of electric field lines, we can write or say where the electric field is more and where the electric field is less. Yes or no? Everyone
Sir.
understand this?
Yes, sir.
Can I have a raise hands from everyone that we understand this? Now, also looking at the spacing and looking at the direction of these electric field lines, again, a lot of things can be understood. Everyone has noted this down? The diagram?
Noted, sir.
Okay, let's move further. And okay, you were doing this. Now let me put this diagram. What will this type of electric field represent? This type of electric field, if it comes to you and you have to draw the diagram and tell me what will this type of electric field represent? What will this type of electric field represent?
Uniform electric field.
Uniform electric field.
This will represent uniform electric field. Electric field which is constant in magnitude. Why it is constant in magnitude? Why it is constant in magnitude? Why it is constant in magnitude? Tell me. How do you understand that it is constant in magnitude? All these are theoretical questions. Question that are going to come in your JEE. How do you understand that this is constant in magnitude?
The distance between two electric field line is same.
The distance between the two electric field lines is same. That means they are constant in magnitude and their direction is also same. That means they are constant in magnitude and constant in direction, and therefore it becomes the case of a constant electric field. Do we understand this?
Yes, sir.
Looking at this type of electric field, this one, this one, what you can say about this type of electric field?
Constant in magnitude but not in direction.
Constant in magnitude but not in direction. Anyone understands this? Anyone understands this? They are equally spaced, but the direction is changing. So probably constant in magnitude, but variable in direction. What about this one? What about this one? Fourth one. Fourth is this. Oops, wrong color. Fourth one is this one. What about this one, beta? Yes.
Non-uniform.
Non-uniform. They are not uniform in magnitude. They are not uniform in direction. Do we understand this? Do we understand this?
Yes, sir.
Yes, sir.
Okay. Then the next point. No electric field lines implies the electric field is zero. Do we understand this? More electric field lines, more electric field, less electric field, less electric field, no electric field line, no electric field. Do we understand this? Anyone understand this?
Yes, sir.
Inside a conductor, in the space of a conductor, electric field is always going to be zero. That implies that electric field lines will not exist inside the conductor. Inside the material of the conductor, electric field line does not exist because there is no electric field. That means whenever you have a conductor, electric field lines will either end there or it will start from there. Whether it ends or whether it starts, it is always perpendicular or normal to the conductor. That is the next point that you will remember. When electric field lines hit a conductor, they are always either normal, entering normally on the conductor, or they are emerging out normally from the conductor. And there has been question which has been asked in JEE specifically on this. So please be very careful about what we are talking here. See, this is the best example that I can give. Here is a conductor, and you can see this electric field line. It is entering the conductor. Inside the conductor, it cannot exist. So it will terminate on this conductor. That means there is a negative charge from this on this conductor. From the other side of the conductor, they might emerge out. But again, even if they emerge out, the angle would be 90 degrees. And here there would be a positive charge. Do we understand this?
Yes, sir.
Similar thing you can see here. They are coming out and they are going in. They are always going in or coming out normally. They are always continuous curves. So you also write this electric field line always form continuous curves. They cannot end abruptly. Whenever they are ending or they are starting, they are always ending if there is a negative charge. They will always start if there is a positive charge. All of a sudden, they cannot disappear. You draw a electric field line like this, ting, and then you disappear and then you start drawing it from here. No, you cannot draw it like this. If it is ending, there must be a negative charge. If they are starting, there must be a positive charge. Do we understand this?
Yes, sir.
They have to be continuous. They have to be continuous curves. They cannot end all of a sudden. They cannot emerge out all of a sudden. That cannot happen. Then this is one property I normally don't discuss, but since someone has said laterally and longitudinally, so I'll give you. Everyone has noted this down? Everyone has noted this down?
Yes, sir.
Then someone said why this electric field line they start to curve because longitudinally lengthwise they contract, whereas they expand laterally, which causes repulsion between two like charges. How do you understand it? It is best understood by this attraction and repulsion, how they contract longitudinally and how they repel laterally. You can see the repulsion laterally. Do you see this? And that is why they become curved. They cannot cut, cross, or touch each other, so repel each other. And they contract lateral, they contract longitudinally. Do we understand this? Huh?
Yes, sir.
The next 2 points, we might not be able to understand it now, but we will write them so that when time comes, we will be able to understand them. So it will be time dependent. Maybe in the next to next class, when we start with electric potential, then you will be able to understand this point. But since we are dealing with electric field in general, so let me write that point as well. And I hope I'll check that I've not missed anything. Everyone noted this down? You see lateral repulsion and longitudinal contraction. You don't have to draw the diagram. You just for you to understand, nothing else. Don't have to draw a very see. I can't draw all these fancy diagrams. That's why I show you this diagram so that it looks good. Nothing else. Shall we move ahead in life? Huh? Electric field lines also give us an indication of equipotential surface. What are equipotential surface? Equipotential surface are surfaces which have the same potential. Now, these equipotential surface should remind you of something that we did some classes back. What we did some classes back. That time also I must have told you about equipotential surface. What did we do some classes back? That should remind you of this equipotential surface now. We did something some classes back in some chapter. The name of the chapter was?
X-rays.
Huh?
Wave optics.
The name of the chapter was wave optics. And the name of this equipotential surface was? What was the name of equipotential surface there? I must have told you something, then only I would have told you this equipotential surface. What did I tell you? It's same as equipotential surface. Wavefront. Wavefront and the shape of wavefront. And I told you that light propagates perpendicular to the wavefront. And this is same as relation between electric field and equipotential surface. Equipotential surface means surface which has points of the same potential, same strength, same ability, same phase for wave. So this electric field lines or electric field actually is perpendicular to this equipotential surface. And we will see how you can find out electric field. We have already done electric field, but we have not done potential. Electric potential is a scalar quantity, electric field is a vector quantity, but we will see how good and how easily they relate to each other. Scalar and vector relating to each other, deadly combination. So electric field lines are always perpendicular to this equipotential surface. And since we have done this, we can also do the last point. Electric field lines are always directed from a point of where to where? Huh? Electric field lines are always directed from a point of where to where?
Positive to negative.
Higher potential to lower potential. Positive and negative means higher and lower actually. So higher and lower are the better terms. Higher potential and lower potential. Do we understand this, or this has gone above and saying bye bye? Sir, enough.
Understood, sir.
Pakka, sir?
Yes, sir.
Okay, sir. Shall we move on to some question and answer, sir? Based on this point, sir?
Yes, sir.
Not cut the correct diagram. No, this I think we have already done, but since it is a problem, and remember the problems on this electric field lines are very, very few. So whatever problems you have to do it correctly. This one is the first one. At which point the electric field is more?
A, sir.
Everyone understand that it has to be A, because A we have what? We have more denser lines. Yes or no?
Yes, sir.
This one, the same diagram that I showed you. So everyone understands this? Now remember, the questions that we have here are very limited, so we have to make the best use of whatever we have. And I don't know why, but I feel that this year maybe you might get a question on based on this. So the question goes like this: if Q1 is 12 microcoulomb, what is the value of Q2?
Less than 12, sir. Microcoulombs and with the negative charge.
You have to give the exact value. It's not saying whether it is less or more. They want the answer, my dear friends. I hope you understand the severity of the problem. They're asking you an exact value. How do I give you the value? Any idea?
-5 microcoulombs.
-5 microcoulomb. Now, how did you get it? All of a sudden?
-8 microcoulomb.
-8. I'm getting one answer as -5. I'm getting one answer as -8. Which is the correct one? And how did you get to this number 8 or 4? That is what I'm more concerned about. How did you get to this number? You tell me that. How did you get to this number? I can't see any number coming from anywhere. How did -5 or -4 or -8 coming? Minus I understand because the electric field lines are going inside. So I can understand that there would be a minus somewhere. But how did you get to that number? कौन बनेगा करोड़पति? अक्कर बक्कर बम्बे वो 80 90 पूरे 100. Since it is less than 12, it has to be 4, 5, 8, or
Sir,
any concrete reason behind it.
Q1 has 6 electric field lines and it is 12 charge. And Q2 has 4 electric field lines, so double than that, 8 microcoulomb.
The universe is beautiful. Open your eyes and see it. And only see what is there. Don't see extra things. We only see 4% of the universe. So only see what is there and don't see things which are not there. Try it again. You have to see only what is there. Don't see something which is not there. And I think you have seen something which is not there. Try again.
Number of lines, sir.
Number of lines, sir. But he also said the same answer, no, sir. He also said number of lines, sir. But the problem here is, sir, that he did not count the number of lines correctly, sir. Now, what do I say, sir? I teach you how to count. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 field lines are going out of Q1. And that's why, and they are saying that it is 12 microcoulomb. So now I have to count how many lines are coming inside Q2. So then I again start 1, 2, 3, 4, 5. 5 are coming inside. Therefore, the answer is minus 5 microcoulomb. See, such a tough question it was. We had to count the number of lines. Such a tough question they ask in IIT. Kasam se. So tough. You have to count till 12. Imagine 12. It's a big task. Anyways, I hope that big task is done and we can do the smaller things. And the smaller version of this problem goes like this. I thought that I'll do this one before, but then I thought, look at the diagram and let's hope that you can give me the answer. If 12 is the number of electric field lines of force from a charge Q are 10, then find the number of electric field lines of force from a 2Q charge. And the answer is, huh? I don't know, sir. Too difficult a question, sir. Yes, my dear friends. What is the answer
20,
for
sir.
Yes,
20.
what?
20.
20. So you just multiply it by 2 and 2 into 10 is 20. So we know the answer. Everyone understands this?
Yes, sir.
This one, in this you don't have an option, sir. But you can tell me how the electric field lines would be. Here comes the question, sir. A metallic slab, and this metallic slab is going to come pretty soon in the next chapter. A metallic slab is introduced between two charged parallel plates as shown in the figure, as shown below. Sketch the lines of force between the plates. Yes, anyone? Huh? They'll give you 3 or 4 different options. And then they will ask you which is the correct one. Anyone? How will they go? So let us say it starts from here, duck, 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 duck. It will go till here, duck, 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 duck. And here we have puck, 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 puck. The negative charge will come here. And this is going to come in the next. Then inside, this is the metal plate. So inside the metal plate, there cannot be any electric field. So what will happen? Electric field will emerge out from the other side. Duck, 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 duck. 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 And this side of the plate would be positively charged. So this is the correct diagram. Do we understand this? It's gone above.
Yes, sir. Understood, sir.
I'm going, don't worry about me. Anyone got this?
Yes, sir.
Sir.
They said this is a question from my IIT-JEE, the year I gave IIT-JEE. When I solved this question in the examination hall.
Yes, sir. Option D.
Option D, sir. So we understand it, sir?
Yes, sir.
It has to end normally, it has to emerge out normally, and that is how the answer comes. Yes or no?
Yes, sir.
Remember, the number of questions here are very few, but those, that is good, because out of those few, some will land up in your paper. Next one. The figure shows some of the electric lines corresponding to electric field. What does we understand from this figure? Nothing, sir. The figure is looking good, sir. I appreciate the beauty of the figure, but I don't understand what we understand. Yes. The figure is fatter at the middle.
Option C, sir. Option C.
And slimmer at the ends. That is what I understand, sir. Nothing else, sir. No, we understand something else. Yes. What is the answer?
Option C, sir.
How did you get option C? Akkad wakkad bambe wo. No. At point A and point C, you can see the same number of electric field lines equally dense. At B, we can see void space. That means electric field at point B is less compared to electric field at point A and at point C. Do we understand this? Yes or no? Huh?
So it's option D.
Option C hoga na beta? You understand this or not? A and C, we have the same electric field, same in magnitude and direction also. And it has to be greater than B. Yes or no?
Sir.
Again, confusion, sir. My description was better, sir. It is fatter at the middle and slimmer at the ends. That is what I understand, sir. Nothing else, sir. Yes, this one. The lines of force of electric field due to two charges, small q and capital Q, are shown in the figure. State if. Dang, 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 dang. 4 options. What I understand in this diagram is, sir, that the diagram is looking good, sir. Apart from that, sir.
Option C, sir.
C, sir.
Option
C,
C.
sir.
Why, sir? Nakkad wakkad bambe so bo, sir. Electric field lines are coming out of Q. So only 2 options can be correct. Q is positive and it is going inside capital Q. So capital Q is negative. So only these 2 options are valid. Now, out of which you have to see from where the number of electric field lines emerging or terminating are more. As you can see, the number of electric field lines emerging out from small q is more. Yes or no? And
Yes,
therefore,
sir.
the correct option is option C. Anyone understands this?
Yes, sir.
Yes, sir.
See, we are picking up some pointers. That's good. Next one, sir. Three positive charges of equal value are placed at the vertices of an equilateral triangle. Dun, dun, dun. The resulting electric field line could be sketched as. Wah bhai wah.
Option C, sir.
Why not B? B is also looking good. B is also looking good. I mean, if it is a part of beauty, B is also looking good for me. C is the correct answer. Why not B? What is the difference between B and C?
Is a circle, sir, in between the charges.
Yes, there is a circle in between the charges. That means the electric field line is going goal, 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 goal. It cannot happen. So that is why it cannot happen. Electric field line cannot be in closed loops. They have to be in open loops. So they cannot be goal, 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 goal. And that is why that is not there. Okay. Let's move ahead in life. In life, we have to always move ahead. This one. Which of the following maps cannot represent an electric field? Batao.
A, sir.
Straight away we have the answers. A, sir. Why, sir? What's the problem with B, C, and D? B, C, and D can exist. Why not A, sir? A cannot.
Option A, sir, non-uniform.
No, it is not non-uniform. This cannot exist. This is a field that cannot exist. It's not non-uniform. This is non-uniform. This is non-uniform. This is uniform. This does not exist. The first one does not exist. Electric field lines cannot be like this. Now remember, electric field is a conservative field. If you move in a closed path, the work done would be zero. That it cannot be zero by any man, any way you understand. So electric field cannot be like it is uniform here and all of a sudden it becomes very non-uniform. Cannot happen that way. You understand this? There has to be some gradual curve
Yes, sir.
coming from there. Cannot just go like this. You understand this? There has to be gradually happening something, but it cannot just do dhada. Yes, it cannot happen like this. Okay. So this one does not exist. Do we understand this?
Yes, sir.
Yes, sir.
This one is again one of the popular questions, even though it is not a part of your curriculum. The conducting plate is not a part of your curriculum, but electric field lines can be traced. This one. A charge Q is fixed at a distance of d from an infinite metal plate. The lines of force are represented by which diagram? I hope everyone is falling in love with its electric lines of force. So beautiful they look. Huh? No one with an answer.
C, sir.
See, sir.
Option A, sir.
It's a fight between C and A. Now let us look at the options. Option B. Looking at option B, it is not possible because one line cannot go like this on the plate and the other line cannot come out of the plate. So this goes Bhagwan ke paas. Coming at option C, it cannot go like this because this is a surface, which is a metal. Line has to come
Yes, sir.
perpendicularly. So this goes to Bhagwan ke paas. Here it falls perpendicularly, but electric field line cannot bend like this, like this. Cannot happen. So obviously this is out of the picture. They cannot just sharply bend like this. They only curve. They are curves, they are not bends. So the only option which is correct is this one. Do we understand it or this is gone about it saying bye bye?
Understand.
Understood, sir.
Okay. Now one more thing which probably may not be a part of your curriculum, but just note it down. I don't know whether sometime they might just give you a theoretical question based on this. So just note this down as a concept. Now let us suppose that this is an electric field line created by some charges, and here I have some charges placed. The charges placed here are Q1 plus Q1 plus Q2 and plus Q3. These are the charges placed over here, and you have some point here. Oops, where is this thing going? Let me not take the point here. Oops, my electric field line is also gone. Okay, there is some point, let us say here, and I join these lines. These are straight lines. I hope you understand this. This angle, I call it as theta1. I call this angle as theta2. And I call this angle as theta3. There could be more charges and there could be more angles. Just a representative diagram. This is electric field line. Obviously, this electric field is created by all these charges together. So you must remember that Q1, and this is without any proof, cos theta1 plus Q2 cos theta2 plus Q3 cos theta3 and so on. This is a constant. Basically, I want to say summation of Qi cos theta I is a constant. Remember this without any proof.
Completed, sir.
Now, this concept is given just for one particular question. This other question, this is might find it in some. If a JEE becomes tough, then probably you can find this question. So basically, what happens here is, you can see, electric field line is coming out from Q1 at an angle of alpha, and it is ending at Q2, which is a negative charge, minus Q2 at an angle beta. They ask you,
Sir,
yes, beta?
sir, once your previous place, sir.
This one. Noted it down?
Wait for 1 minute, sir.
Okay.
Yes, sir.
Okay, noted this down. When this is for this particular question, you might need this. There's one more way in which you can do this. But so the question is like this. At Q1, which is a positive charge, electric field line comes out of Q1 at an angle alpha, and it ends up at Q2, which is a negative charge, with an angle beta. If you know the angle alpha and you know values of Q1 and Q2, what is the value of angle beta? Oh, they can ask you in a different way. What is the ratio of sine alpha by sine beta or something like that? So basically, you have to find the relation between alpha, beta, Q1 and Q2. That is the entire question. I give you 2 minutes to try it. So alpha, beta, let us say everything is known. Alpha is known, beta is known, Q1 is known, Q2 is known. Find the relation between Q1, Q2, between the four of these quantities. That can be the question. The actual question is find the angle beta.
Sir,
Yes?
Q1 cos alpha plus Q2 cos beta is constant.
It is not constant, beta. It is not at the same point that you are applying it. It was constant when the point was same. Okay. So what you got to do is, the way of solving this problem is, if you call this point as A, you call this point as B. Now, at point A, the angle that the line from Q1 makes will make an angle alpha, yes or no? And the line from B, from minus Q2, will make an angle of pi, 180 degrees. If I draw this, the line from here, the point from here will come like this and join it here. So the angle is 180 degrees. And since it is coming out from point A, the angle would be alpha. So the first equation that you will get will be like this. The first equation that you will get will be like this. Q1 cos alpha, this is at point A, minus Q2 cos of pi is 0. Not 0, is constant. This is the upper wali equation applied at point A. Do we understand this? Then if I apply the same equation at point B, for point B, the line joining A with point B is going like this. It makes an angle 0. The line joining B to that electric field makes an angle of 180 minus pi. So it looks like this. Q1 cos 0 minus Q2 cos of pi minus beta is constant. And this constant, because they are on the same electric field line, this constant is same. So now you equate the two. If you equate the two, what you have to remember in general sense, what you are going to get is this relation. If you just remember this relation, you don't have to fall into all this trap. Q1 into 1 minus cos alpha will be equal to Q2 into 1 minus cos beta. This is the relation that you will end up with. And this is the relation that you must remember. Or you can remember it like this: 2 times Q1 sine square alpha by 2 will be equal to 2 times Q2 sine square beta by 2. So just remember this relation. Don't have to remember what I had given you. The point that I had given you was just for a theoretical question. If they ask you directly that one, then you remember that equation. Otherwise, for this question, and that is the only question of this type, you just remember this. From here, if alpha is given, you can find out beta. If beta is given, you can find out alpha. If they ask you the ratio of alpha beta or ratio of sine alpha sine beta, you can find out their ratios as well. Do we understand this? This is what you should remember, nothing else. I'll give you 2 minutes to note this down. Once you have noted it down, please let me know.
Done, sir.
Everyone, sir?
Yes, sir.
Completed, sir.
Okay. Then that brings us to your favorite topic, which we're waiting for so long. And finally, we write the heading of that topic, and the heading of that topic is electric flux. So let's write the heading, electric flux. Electric flux. Now, as soon as we get into this topic of electric flux, the first type of thing, the first term that we have to understand is known as area vector. Have you heard about this term, area vector? Area in physics is treated as a vector. Area is treated as a vector from wherever we are going to treat area in physics. Area is treated as a vector. Now, as soon as you start to treat it as a vector, there are two things that you must be concerned about. What are the two things that you must be concerned about? One is the magnitude of area, one is the direction of area. Now, the magnitude of area you have been dealing since standard third or fourth. The area of a circle is pi r square. The area of a rectangle is a into b. So you all know about the magnitude of area, yes or no?
Yes, sir.
The only new thing that we are going to do or understand here is the direction of area. And what is the direction of area? Taken as? The direction of area is taken as perpendicular to the area or perpendicular to the surface. You are writing on a table. Your table is a surface. What is the direction of area vector of that table? It is perpendicular to that table. That is taken as the direction of area vector. Do we understand this?
Yes, sir.
Perpendicular. Perpendicular to your area. If this is your surface, if this is your area, or this is your area, the direction of area vector is like this, perpendicular. If this is your area, the direction of area vector is like this. It is taken perpendicular to the surface. But as soon as we talk about this area vector or area, or we talk about surface, we must understand that there are two types of surfaces that we are going to come across. Closed surfaces and open surfaces. Now, this closed surface is a term that you must understand very carefully. What is a closed surface? Any surface which encloses a volume. Any surface which encloses a volume is known as a closed surface. Example, this bottle. This bottle has a volume. This is a closed surface. If I move around this surface, I will always remain on the outer surface and I will never get inside this. So it has a distinctive boundary between outer surface and inner surface. This is the outer surface. If it is closed, I cannot get onto the inside of this. That is a closed surface. Now for a closed surface, the area vector is always taken as outward normal. Because for any area, if I draw this area, if I have an area like this, the area vector can go in this direction. This is also normal. The area vector can also come in this direction. This is also normal. The point is which direction you should take as the direction of area vector. So remember, if it is a closed surface which encloses a volume, it must be taken as a outward normal. If it is an open surface, now what is an open surface? A surface which is open is open. That means if the bottle, if I open the cap of this bottle, it does not remain a closed surface. It becomes an open surface because now water is going to spill if I do it this way. But if I close it, water does not spill. So this is the best way of understanding closed surface and open surface. This is a closed surface. Closed almirah is a closed surface. An open almirah is an open surface. A closed room is an closed surface. A room with a window or a door open is an open surface. A table, the top of a table is an open surface. The wall is an open surface. Do we understand the difference between an open surface and a closed surface? So for a closed surface, and this closed surface is very important because your favorite topic, Gauss law, only talks about the closed surface. So this is a closed surface. This is a closed surface. A surface which encloses a volume is a closed surface. For a closed surface, the direction of area vector is always taken as the outward normal. For an open surface, you can take it any normal, whether it is outward or inward. Normally, the direction of area vector for an open surface will be given to you in the question itself. So if it is an open surface, the direction of area vector will be given to you. If it is a closed surface, it will not be given to you. You have to take it as the outward normal. When I say outward normal, what do I mean? If this is a closed surface, the area vector of this side will go like this. It cannot go inside the surface. It has to go outside. The area vector of this surface will go like this. The area vector of this surface will go like this. The area vector of this surface will go like this. The area vector of this surface will go here. The area vector of this surface will come over here. It is always the outward normal. Do we understand this? This has got 6 or 7 faces. Every phase will have its outward normal coming out. Do we understand this? That is how we understand the area vector of a closed surface. Okay. For a closed surface, it is taken at outward normal. For open surface, it will be given to you. It could be this normal, it could be that normal. Depends on how this problem is done. Okay, so what we'll do is we cannot do anything else in this class because the time is already over. So what we'll do is we'll continue with this electric flux and Gauss law in your next class, next chapter, and probably by the end of this week, we must be done with this and we must start the electric potential wala chapter. So take care. Have a nice day. God bless you all. Let me know if there is anything that is troubling you. Bye bye.
Thank you, sir.
No, sir. Bye, sir.
Bye, sir.
Bye.